Hi, Accelerated Physics. In this video, I want to help you launch your water balloons and think about the different angles that you can launch it at. So the first thing is you just have to choose the angle your water balloon is going to launch. So I'm going to say that my water balloon is launching with, let's say, 20 meters per second. So that is always going to be the hypotenuse of your triangle, because when you change the launch angle, you're not actually changing the initial velocity. You're simply changing at what angle that velocity is going to move at, right? You're changing the direction. So I'm going to draw my components here. So I have my Vy and my Vx. I'll make sure to calculate these correctly. And let's say I'm going to launch this at, let's say, 65 degrees. Okay. So the first thing is time is not known. So when you launch your water balloon straight up into the air, you're actually giving it the maximum time in the air, right? If I want to give an object more time in the air, I'm actually going to give it more velocity in the vertical direction. So if I launch my velocity totally, or if I launch my water balloon totally in the vertical direction, I've given it the maximum amount of time possible for my water balloon to be in the air. So as I lower the angle, right, instead of making it 90 degrees, I make it 65, right, I'm going to have less time. And I don't know how much time is going to be in the air, so that's going to be the first thing that I calculate, just like we did in the notes. So I'll make my XY table just like normal. XY. I know acceleration is negative 9.8. And I know that I want to find my distance in the X, right? That's always the thing that I want to know. I want my velocity in the X and my velocity initial over here. I know my velocity at the apex is 0. So that is the beginnings of my XY table. So I know Vy is going to be the 20, and then this is on the opposite side, so I'm going to use sine of 20 degrees, or sorry, 65. So we should get 20 sine of 65 gives me 18.1. So this goes over here, 18.1 meters per second. Then my velocity in the X is going to be 20 cosine, because it's on the adjacent side, 65 degrees. Gives me 8.5 meters per second. 8.5 meters per second goes here. All right. So again, if I want to find distance in the X, right, it's always going to be this equation, but I do not know time. So I'm going to go over to the other side, and I'm going to try to find time. Remember, we want time total, not just time to the apex. So it's going to be 0 minus 18.1 divided by negative 9.8. It's going to give me a time in the air of 1.85 seconds. Then my time total is double that. Whoopsies. Time total is 2 times 1.85 seconds. So that gives me 3.7 seconds. And now I can plug it back into my distance equation here. And that's going to be 8.5 seconds. Well, actually, let me put the velocity first. So that's going to be a velocity of, oh, actually, that was right, sorry, 8.5 meters per second times 3.7 seconds. And I get a distance in the X of 31.45. So actually, this would be a really good distance to launch my water balloon for the 30 meters. Think about the fact that I have a height, right? So if the water balloon lands behind me, it's going to have to go through some height. It's still not at height 0. So this water balloon might pass through me. Maybe I want to adjust it a little bit down or a little bit up, depending on which one will make the distance smaller. So if I have this distance, let's say I wanted to make it smaller, right? Let's say I wanted to get it to 30.45 or something within that range. I would have to try out a new angle because this one doesn't work as precisely as I would like it to. So I just have to adjust it by a bit, but I'm going to have to redo the whole calculation. So this is why I put you in groups, is so that you can try out these calculations a couple of times. Okay, I hope this helps you think about the time and the angle of the launch and where your launch velocity goes on your vector triangle. All right, see you later, physics.